Hello everyone, this is Aditya sir, and today we are going to talk about some of the concepts of compressible flow. Compressible flow basically means the flow which can be compressed. Okay, and this compression results in some of the physical phenomena which is commonly observed when an object moves through the air. So we'll try to understand what is this speed of sound, what is Mach number, and what happens when an object actually tries to travel faster than the speed of sound as a part of this work. Fine. So first we'll try to understand what is basically disturbance. So disturbance is basically, as you can see, it is excess energy. Okay, nature always, so most importantly, nature always prefers equality and equilibrium everywhere, right? Whenever there is excess energy due to man-made activity, a chemical reaction which has taken automatically, or maybe decomposition of a very big rock or a stone inside the earth, as you can see here, this activity actually results in production of excess of energy. So what happens when a disturbance is generated into the nature? So whenever a disturbance, excess energy is generated in the nature, okay, this energy actually nature tries to balance this energy. Like I told you, nature always prefers equality. So what nature does is it tries to transfer that energy from one place to another place in the form of a wave. Okay, this is basically a wave. So energy is transferring at a certain pace in all the direction, actually same pace in all the direction. This results in the formation of ripples. Similarly, this is the ripple by throwing the stone which we generate, and this is the second thing. Let's say under the earth, if there is decomposition of a very big rock, so then that rock is going to produce ripples here around, and these ripples actually at the epicenter, the waves are actually generated from the epicenter, and then like we have seen in the form of ripples, the earthquake also, the seismic waves also, they move across the crust of the earth's surface. So every disturbance is actually generated and transferred, the excess energy is transferred in the form of waves, and it in all the direction at the same speed. So this is how nature actually tries to balance the excess energy which is generated here, right? Then next thing is, what is a speed of a sound? Speed of sound basically implies sound, the speed or the pace at which the sound propagates through a medium, right? So sound is basically a pressure pulse. You can see the pressure here. So there is a disturbance. This loudspeaker is actually creating a disturbance, and this disturbance is actually getting transferred towards the other end, or the other end of this duct or one-dimensional channel, in the form of these particles. At some places the particles are very close to each other, high density region, which is called compression, and at other places the particles are far away from each other, so this region is actually called rarefactions. Actually the disturbance which is created here, it is getting transferred because of oscillating particle, or in the form of compression or rarefaction, to the second end of this particular rod. So this is how energy is transferred from one place to another place, and if it is getting transferred in all the directions, again it will form a ripple. If it is in air, the formula to calculate the speed of sound is very simple. A is equals to nothing but gamma p by rho, and even more simpler, because speed of sound is function of temperature of the medium. We have gamma r, and that is T, where R is adiabatic index, gamma is gas, capital R is gas constant, and T is basically a temperature. For air, which is also considered to be a calorifically perfect gas, so for calorifically perfect gas or air, gamma is equals to 1.4, and R is equals to 287, and temperature is measured in Kelvin at a given altitude. As we move away from the surface of Earth, the values keep on changing.